Welcome to This Explainer. Okay, today we are diving headfirst into what I like to call the absolute greatest cold case in the history of our planet. We're going to completely separate the facts from the fiction when it comes to how life developed on Earth. Evolution is such an elegantly simple concept, but man, it detracts just a massive mountain of misunderstandings. So we're going to treat this whole thing like a true detective story, tracing the biological clues to see exactly what the evidence actually reveals. Let's start by opening up a mystery box. When you look around at the staggering, intricate diversity of life, we're talking everything from microscopic bacteria to giant redwood trees and birds soaring in the sky. It just seems completely impossible that all of this could have emerged from pure randomness, right? Like, no way could such complex designs just happen. It's one of the most common questions people ask. And to solve it, our very first step is that we have to completely shift our perspective on time. To really wrap our heads around the immense scale of this investigation, we first have to grasp this concept called deep time. Take a look at this. A river, cutting deep through a plateau like this, reveals layers of sedimentary rock that were deposited over 1 billion years ago. Think about that for a second. The Earth is incredibly, unimaginably old, and biological evolution has literally had billions of years operate. That vast, mind-boggling expanse of time is the foundational canvas on which the entire history of life has been painted. So, the crucial point we're establishing here is that we are looking at macroevolution. This is evolution on the grand scale. It's the overarching framework that maps out the genealogical family tree of absolutely all terrestrial life. We aren't just talking about tiny, minor changes within a single isolated population. We're talking about common ancestry, descent with modification, and massive structural transformations over millions and millions of generations. Now, let's smash our first big misconception right out of the gate. You hear it all the time, right? People say, well, evolution is only a theory. But that completely stems from a misunderstanding of the word itself. In everyday language, a theory is just a hunch, like, having a theory that your coworker keeps stealing your pen. But a scientific theory, that is a rigorously tested, empirically validated framework. In science, evolutionary theory sits confidently right alongside the theory of gravity and the germ theory of disease. In fact, as biologists continuously piece together the clues left behind in nature, actual physical change over time and common descent are treated as undeniable, observable facts. As researcher Keith Stewart Thompson brilliantly put it, the logic is so unassailable that we just act as though it is a fact. Scientists literally no longer debate whether evolution occurred. Instead, all that vibrant, active research today is focused entirely on how those specific mechanisms actually operate. All right, let's dive into another classic false lead. The renowned astronomer Fred Hoyle once made this really famous, egregious blunder. He claimed that natural selection creating a functioning organism is about as likely as a tornado sweeping through a junkyard and just randomly assembling a Boeing 747. And hey, I'll admit, that sounds like a great argument at first, but it fundamentally misunderstands how our primary suspect in this case, natural selection, actually does its job. Evolution absolutely does not build complex things all at once by sheer accident. So here's what's actually happening under the hood. While the genetic mutations that give us our raw building blocks are indeed random, natural selection itself is emphatically non-random. Think of natural selection as this relentless, unavoidable detective work. It's constantly sifting through genetic diversity, picking and choosing the specific options that fit the environment the absolute best. It repeatedly keeps the useful traits, tosses the bad ones out, and accumulates those adaptive changes generation after generation. Honestly, it's spectacularly effective at producing highly non-random outcomes. Now, you're probably thinking, okay, if this is a continuous chain of events stretching back billions of years, entirely driven by natural selection, where are all the missing links? If creatures slowly transformed from aquatic fish to land-dwelling animals, shouldn't the Earth just be absolutely packed with the physical remains of these half-and-half creatures? Well, we really have to remember that physical evidence from hundreds of millions of years ago is understandably going to be full of gaps. Why? Because a dead creature perfectly fossilizing is a stupendously rare event. Actually, scratch that. It's rarer than winning the lottery. The vast, overwhelming majority of organisms that have ever lived just decomposed without leaving a single trace. So finding an intact fossil is literally like finding a needle in a continent-sized haystack hundreds of millions of years after the fact. But, every once in a while, the Earth just hands us a smoking gun. Back in 2004, up on a freezing island in far northern Canada, researchers discovered Tiktaalik. When you trace its lineage, Tiktaalik perfectly bridges the gap between water-bound fish and land-dwelling animals with four legs. It is the ultimate transitional fossil. What makes this guy such an absolute game changer is its perfect blend of intermediate features. I mean, it looked like a fish because it had gills, scales, and fins, but it also packed highly advanced features. It had evolved lungs, a flexible neck, and most importantly, a super sturdy fin skeleton containing bones that formed a limb-like appendage. This creature was literally capable of propping itself up in the shallow waters. It basically confirmed a massive prediction evolutionary biologists had been making for over a century. Now, despite incredible smoking guns like Tiktaalik, we still run into another major claim in this investigation, the concept of intelligent design. This is the idea that certain biological systems, like the vertebrate eye or tiny microscopic cellular mechanisms, are just too complex to have evolved step by step. They call it irreducibly complex. The whole argument is basically, if you remove one part, the whole system stops working, so therefore, it must have been designed all at once. But when scientists actually trace these biological breadcrumbs down at the molecular level, that claim kind of just dissolves. They find that these complex systems actually evolved by co-opting and modifying simpler systems that were already there. For instance, the complex bacterial flagellum, which is like a tiny molecular motor, shares a direct evolutionary origin with much simpler proteins that bacteria use to inject toxins. Same goes for the complex blood clotting system in mammals. It was built step by step using genetic parts already present in earlier fish and reptile ancestors. Turns out, nature's just the ultimate recycler. Okay, so we've cracked the deep ancient history and the tiny molecular biology, but let's bring it back home to the present. How does this build into our own lives right now? Because a very common misconception is that human beings are somehow exempt from all of this. We tend to think that because we have modern medicine and technology and air conditioning, we've essentially hit the pause button on our own evolution. But remember, you, yes you, watching this, are actively part of this ongoing process. Sure, evolution is a really slow process, but field studies definitively prove humanity is absolutely still adapting today. For example, if you can comfortably drink a regular glass of milk right now without feeling awful, that lactose tolerance is actually a relatively recent evolutionary superpower. We're also seeing genetic resistance to malaria developing in certain regions, and whole populations evolving the physical ability to effortlessly thrive at extremely high oxygen-deprived altitudes. So the evidence is pretty undeniable. This great evolutionary cold case, it isn't cold at all. It is a highly active, totally ongoing investigation. And our environment is rapidly shifting right now due to climate change, new diseases, and totally different diets. Which leaves me with one final question for you to chew on. As natural selection continues its relentless everyday work, what fascinating, mysterious traits do you think our species will be forced to adapt into next? Thanks for joining me on this explainer, and keep questioning the world around you.